This question was asked in the GATE Physics paper 2021. This is a MCQ type 1 mark question. This question is from the topic electromagnetic theory. The question is, consider a tiny current loop driven by a sinusoidal alternating current. If the surface integral of its time averaged Poynting vector is constant, then the magnitude of the time averaged magnetic field intensity at any arbitrary position r vector is proportional to option A 1 by r cube, option B 1 by r square, option C 1 by r, option D r. So we have to choose the correct option. Let us see the solution now. We have to consider a tiny current loop. Now a tiny current loop is basically analogous to a oscillating dipole. So we can consider a tiny current loop as a oscillating dipole whose Poynting vector is S vector equals to E cross H, where E vector is the electric field and H vector is the magnetic field intensity. It is also given the surface integral of its time averaged Poynting vector is constant. So the time average of S vector will be this, and which is basically time average of E cross H. Now, according to the question, the surface integral of the time averaged Poynting vector is constant. In the surface integral, this dA vector is the differential surface area vector. Now, if we represent this dA vector in the spherical polar coordinate, then it will become r square dr sine theta d theta and d phi. So basically, dA vector is proportional to r square. So if the surface integral is constant, then it will lead to this time averaged Poynting vector will be proportional to 1 by r square, so that this surface integral will be constant. Now from this we can conclude our time averaged electric field vector will be proportional to 1 by r, and the time averaged magnetic field intensity will vary as 1 by r. If you remember the case of oscillating dipole, for an oscillating dipole, both the electric field and magnetic field varies as 1 by r. So among these four options, the option C is the correct answer, that is 1 by r.